All right, so today we're going to be taking a deep dive into deep learning. And
Yeah.
I know everyone listening is really curious how these models, the one that's powering
Right.
ChatGPT,
Yeah.
actually learns.
Yeah.
And we're going to be using a lecture by Ricardo Calix from his
Mhm.
YouTube channel as our guide today.
Yeah, Ricardo Calix does a really great job, like breaking down complex concepts and
Yeah.
making them a little more accessible. So
Yeah, he really gets into the nitty-gritty of training algorithms, but we're going
yeah,
to make sure that you come away understanding
right.
the key ideas, even if you're not a math whiz.
Yeah, and I think we could definitely connect some of these concepts back to
Okay.
things that folks might already be familiar with.
So he starts by diving into the math behind deep learning, specifically derivatives.
Yes, and that's such a fundamental piece of the puzzle here.
Okay.
These derivatives are essential for helping the model find the best solution.
Right.
Kind of like a compass, guiding you to the lowest point in a valley.
Okay, that makes sense. But I remember Calix actually walks through
Yes.
a step-by-step derivative calculation in the lecture.
He does.
And it seemed pretty involved, even with a simple example.
It is. Yeah.
So what's the takeaway for us non-mathematicians?
Yeah. So what's fascinating is this, like, seemingly tedious process of calculating derivatives
Right.
that's happening all the time behind the scenes in these massive deep learning models.
Wow.
But here's the good news.
Okay.
We don't have to do it manually.
That's it.
Frameworks like PyTorch take care of all those calculations for us.
Oh, wow.
They build what's called a computational graph, which maps out all the mathematical operations. And then they use something called the chain rule to automatically calculate all the derivatives.
So PyTorch is doing all the heavy lifting in the background.
Exactly.
That's a relief.
It lets us focus on the big picture,
Okay.
which is training the model effectively.
All right.
And speaking of training,
Yes.
Calix then shifts gears to talk about the learning rate.
Right, the learning rate. I remember that being a key parameter.
It is a key parameter, and it controls
Yeah.
how quickly the model adjusts its internal settings or its weights to improve its predictions.
Okay.
You can think of it like adjusting the temperature on a thermostat.
Oh,
You make huge adjustments,
Mm.
you might overshoot that comfortable temperature.
right.
But if you make tiny adjustments, it'll take forever to get there.
So finding the right learning rate is kind of like finding the sweet spot.
Precisely.
Yeah.
And Calix actually demonstrates this with a simple coding example where he trains a model to predict Celsius from Fahrenheit.
Right. And that example really highlights the core process of deep learning, even though, as you mentioned, there's a simple formula for that conversion.
Absolutely. It boils down to this cycle.
Okay.
The model makes a prediction.
Mm.
We calculate how far off it is from the actual value. That's called the loss.
Okay.
We use those derivatives to figure out how to adjust the weights to reduce the loss, and then we update the weights based on the learning rate. And we just repeat this whole process over and over again.
It's amazing that this seemingly simple process can lead to such sophisticated models.
It really is, and this is where Calix makes a really important point.
Okay.
A student asks him, why not just hard code the formula instead of training a model?
Right.
Especially in cases where we already know the equation.
Especially something simple like that.
Right, exactly. And Calix highlights that in many real-world scenarios,
Mhm.
we don't know the formula.
That makes a lot of sense. If we already knew the answer, we wouldn't need machine learning in the first place.
Exactly. Deep learning allows us to learn from data, potentially uncovering hidden patterns and relationships
Right.
that we wouldn't have discovered otherwise.
Yeah.
This is especially important in fields like healthcare and scientific research, where there's still so much we don't know.
So deep learning is like a powerful tool for exploring the unknown, uncovering those hidden gems in the data.
Exactly. And this brings us to another critical concept that Calix touches upon,
Okay.
unsupervised learning.
Unsupervised learning sounds a bit mysterious.
It does kind of have that air of mystery to it.
Yeah. So what's the key difference between that
Yeah.
and the supervised learning that we've been discussing?
So with supervised learning, we're giving the model labeled data like those Fahrenheit and Celsius pairs,
Right.
and it's learning to make predictions by comparing its output
Okay.
to those known answers.
Gotcha.
But in unsupervised learning,
Okay.
we're giving the model data without any labels or explicit instruction. It's like giving someone a giant jigsaw puzzle without the picture on the box.
So it's more like exploration and discovery.
Exactly.
The model has to figure things out on its own.
Yeah, unsupervised learning is all about uncovering hidden patterns, structures, relationships in the data itself.
That sounds like a pretty challenging task.
It can be.
How does the model even know where to start?
So that's where some clever techniques come in.
Okay.
One common approach is clustering,
Okay.
where the model groups similar data points together Imagine you have a collection of different fruits,
Okay.
and you want to categorize them without knowing their names.
Right.
An unsupervised learning algorithm could group the fruits based on characteristics like color, shape, and size,
Uh-huh.
essentially forming clusters of apples, oranges, and bananas, even without knowing what those fruits are called.
So it's like the model is creating its own categories
Yeah.
based on the inherent similarities in the data. That's fascinating.
It is, and another powerful technique is dimensionality reduction.
Okay.
This is all about simplifying complex data by finding a way to represent it in a lower dimensional space
Mm-hmm.
while preserving its most important features. Think of it like creating a concise summary of a long book. You capture the key ideas without all the extra details.
Okay, I see how these unsupervised learning techniques can be incredibly useful for making sense of vast amounts of data.
Yeah,
But I'm curious, how does all of this connect to language models like ChatGPT?
that's where the concept of embeddings comes into play.
Embeddings, okay.
Embeddings are essentially a way to represent words or phrases as numerical vectors, a series of numbers that capture their meaning in relationships to other words.
So it's like giving each word a unique numerical fingerprint.
That's a great way to put it, and the really interesting part is that these embeddings are often learned using unsupervised techniques on massive amounts of text data.
So the model is essentially learning the underlying structure of language by analyzing huge volumes of text, and then it's using that knowledge to create these numerical representations of words.
Precisely. And these embeddings are incredibly powerful because they allow us to represent language in a way that computers can understand and manipulate.
Okay.
They allow us to do things like find similar words,
Yeah.
complete analogies, and even translate languages.
I can see how that would be crucial for a language model like ChatGPT, which needs to understand the nuances of language in order to generate human-like text.
Absolutely. It's like ChatGPT has learned the secret code of language through these unsupervised learning techniques and the creation of these embeddings.
It's all starting to click. Now we've gone from the mathematical foundations of deep learning with derivatives to the process of training models
Right.
to the exciting world of unsupervised learning and embeddings.
Yeah.
It's amazing how these seemingly disparate concepts all come together to power these incredibly sophisticated AI systems.
It really is a testament to the power of algorithms, data, and human ingenuity.
Yeah.
But what's even more exciting is the potential that deep learning holds for solving real-world problems.
Okay.
Calix briefly touches upon this in his lecture, highlighting how this technology is already making significant impacts in various fields.
Yeah, it feels like we're just scratching the surface of what's possible with deep learning.
I think so too.
Yeah.
There's so much potential there. So what are some real-world applications
Yeah.
where these techniques are really shining?
Yeah, where is this actually being used right now?
So one area that Calix highlights is recommendation systems.
Okay.
The kind that suggests products you might like or movies you might enjoy.
Right, right.
And many of these systems rely on unsupervised learning to analyze your past behavior and group you with similar users.
Okay.
And this allows them to make surprisingly accurate recommendations.
Yeah, it's almost like having a personal shopper who knows your tastes better than you do.
Right.
I've definitely been impressed by some of the recommendations I received.
Yeah, me too.
Right, yeah.
It can be a little spooky sometimes how well they know us.
Yeah, for sure, for sure. What other areas are seeing a big impact?
So another area is anomaly detection.
Okay.
Unsupervised learning is incredibly good at identifying unusual patterns in data
Yeah.
that could indicate fraudulent activity, equipment malfunctions, or even potential health issues.
Wow.
Think of these systems like vigilant watchdogs, constantly scanning for anything that deviates from the norm.
That's a powerful application. It's like having an early warning system
Exactly.
for a wide range of problems.
Yeah, it really is.
So, but what about those embeddings that we talked about?
Right.
How are those being used in practice?
Yeah, so embeddings are really revolutionizing natural language processing.
Okay.
One compelling example is machine translation.
Mm-hmm.
By representing words and phrases from different languages in a shared embedding space, we can train models to map meanings across languages, leading to much more accurate and nuanced translations.
So it's like creating a universal language map.
That's a great way to put it.
That connects the meaning of words across cultures. That's pretty amazing.
It is.
Any other examples that come to mind?
Yeah, Calix also mentions how embeddings are driving advancements in text summarization.
Okay.
By understanding the relationships between words and sentences in a document, AI systems can now generate concise summaries that capture the essence of the content, saving us a lot of time and effort.
It's like having an AI assistant who can read through those lengthy reports and distill the key points for us. That would
Exactly.
be incredibly helpful in so many situations.
Well, absolutely. Imagine all the time we could save.
Yeah.
And what's really fascinating is that this is all based on those core principles of deep learning that we've been exploring. Derivatives, the chain rule optimization, and the power of learning from data.
Uh-huh.
Whether it's supervised learning or unsupervised learning, these fundamental concepts underpin the remarkable capabilities of AI.
It's really incredible to see how all of these pieces fit together. We've gone from the theoretical underpinnings of deep learning to these practical applications that are already having a significant impact on our lives.
And this is just the beginning.
Right.
As Calix points out, the field of deep learning is constantly evolving. New discoveries and advancements are emerging all the time. And it's truly a thrilling time to be witnessing this technological revolution.
This deep dive has been an eye-opening experience. We've gained valuable insights from Ricardo Calix's lecture, and it's clear that deep learning has the potential to transform countless aspects of our world.
I completely agree. And for our listeners, I encourage you to continue exploring this fascinating field. Dive deeper into the resources we provided in the show notes. And who knows, maybe you'll be the one making the next groundbreaking discovery in AI.
That's a great point. This deep dive has given us a solid foundation, but there's always more to learn and explore, so keep that curiosity burning. And until next time, happy deep diving.